I'm in the middle of a major AI overhaul for cargo defense, and unfortunately it's not in a working state to demonstrate right now. So instead, I'll be talking about a few popular AI approaches and the hybrid approach I'm working on. It's kinda sorta mostly finished, so I think the plan is pretty solid, but you never know when some unforeseen complication will require me to change something. First, let's talk about a few general approaches. I didn't know what it was called at the time, but my first approach was essentially a decision tree. You might recognize this diagram from my second vlog. A diagram like this basically translates to a bunch of if statements, checking various conditions to arrive at a decision about what the AI should do. This is fine for simple games, but to handle tactical combat well, it would have to be insanely complex. It would also be difficult, if not impossible, to integrate possibilities from modded content. My second approach was essentially a utility-based AI, although I didn't know that name either at the time. This is a broad category with many variants, but the general idea is to assign a score to every possible action and pick the one with the highest score. This is much more manageable and would be easy to extend for modded content, but it lacks foresight. By focusing on just the next action, it can't predict that a sequence of actions would yield a much more valuable outcome than the sum of its parts. Unless, of course, you augment this approach with something else. I took one step in that direction with movement. When evaluating possible moves, I would score them based on what could be done after the move, but this was still short-sighted. It would only plan as far ahead as one move and the non-move actions that could fill the rest of the turn. A lot of people in the comments recommended GOAP, so that's what I looked at next, but to explain it, let's first look at what it was based on. The Stanford Research Institute Problem Solver, or STRIPS. The process starts with an initial state, a goal state, and a set of actions. Each action has a set of preconditions and a set of postconditions, or changes that it makes to the state. From there, it's just a matter of finding the shortest sequence of actions to get from the initial state to the goal state. Fortunately, this translates easily into the kind of graph traversal problem that's been widely studied in computer science and has plenty of well-documented solutions out there, such as the A-star algorithm. You won't be able to just plug this into the A-star implementation that comes with Godot, but it's pretty easy to write your own to handle this. The problem in applying strips to a complex game scenario is the rigidness of those pre- and post-conditions. They're all yes or no variables, and the list is determined up front for each action. So for instance, if an attack action needs a line of sight to the target, how do I express that in a precondition? Even if I have a variable in the state for whether or not there's a line of sight between every combination of units, when a unit moves, strips doesn't allow for dynamically updating them based on the environment. That's just one of many complications. Goal-oriented action planning, or GOAP, improves on this technique by adding procedural pre- and post-conditions. Instead of checking against a preset list of requirements for an action, the action provides a function to evaluate whether or not it's available by whatever criteria necessary. Similarly, it provides a function to update the state in any way desired. This isn't the only change introduced by GOAP, but personally I think it's the most important. The reason I bring up the difference between strips and GOAP is I ran into some misinformation online that had me confused for quite a while. Some of the discussions and example code I found first when researching GOAP didn't have dynamic pre- or post conditions, so I was stumped as to how I could make that work for the AI and cargo defense. Some descriptions I saw of GOAP also described working backward as an integral part of the algorithm, starting with the preconditions of the goal and finding what actions could satisfy it. This backward traversal approach is perfectly valid, but as far as I can tell it's not part of Jeff Orkin's original design when he invented GOAP. And when I tried it, I found it made things much more difficult. I'll come back to that later. Now that I have a better understanding of GOAP, there's still one problem for my purposes. If I rely on GOAP alone, what's the AI's goal state? Retrieving all the cargo? Killing all your units? 0 casualties on the AI side? But I want to be more flexible. Maybe that ideal outcome simply isn't possible, and some trade-off needs to be made. I could retry with less and less ideal goals until I get one that's achievable. But when we're talking about planning out the entire encounter with many possible actions at each step, I suspect it's going to get problematically time-consuming, and the whole process will have to be repeated every time the AI gets new information. This is a turn-based game, so I could be wrong about it being too slow. It doesn't have to run every frame. But at least until I can start timing things to find out, I'm taking a hybrid approach. Rather than set the goal as the end of the encounter, I produce a list of short-term goals. One for each unit the AI wants to kill, one for each piece of cargo it wants to steal, one for reducing the danger for each of its units, up to 10 exploration goals, and once the AI is satisfied with its haul, a goal for escape. I then use GOAP, or an almost identical process, to try to generate a plan for each goal. Each plan is scored based on a utility score for the goal and the cost of the plan to get there, and any plan in progress that can't beat the current best is aborted early to save time. I'm expecting generating a few dozen short plans to be faster than generating one long one, and the memory overhead will definitely be less, but I also think this will feel more like you're playing against another person. I doubt most human players will think more than a few moves ahead, and this is still much better foresight than my previous approach. It can pursue goals that will take multiple turns to complete, and thanks to GOAP, it can use any means available, including actions provided by equipment or items added by modders in the future. So back to the forward versus backward traversal thing. I flip-flopped on this a couple of times actually, partly because at first I thought backward traversal was the established way to do it, and there must be a reason. I thought perhaps starting from the goal's requirements, and only looking at actions that satisfy something I know I need would make it faster. But once I got deep into implementation, I started having to do a bunch of awkward special cases. It started out simple enough. The goals generate a list of requirements, then I ask each action, what would it take for you to satisfy one or more of these requirements? If there's any circumstance under which an action can fulfill a requirement, it provides a new list of requirements that combines both the leftovers from the original set and anything new it needs to satisfy one. If there are multiple ways to satisfy a requirement, it returns a list of requirement sets. Each of those sets is another branch in the possible path backward. Now here's where things start to get complicated. Units have a limit to how many actions they can take per turn. Let's call them action points to keep terms separate. Each action that requires an action point adds to the number of action points required as a precondition. But when that number gets too high, the only way to satisfy that requirement is to insert an end turn action. However, the AI should try to avoid ending its turn with a unit in the line of fire of a bunch of enemies. The problem is the AI doesn't know yet where the unit will be when the turn ends. It's perfectly fine to move into a dangerous spot in the middle of a turn, as long as the unit moves to safety afterward, so I only want to check the danger level for the next move in the backward planning sequence after an end turn. This one case is easy enough to solve, but what if I add a teleporter? It should try not to teleport to a dangerous spot at the end of the turn either. As I add more and more special cases, that's more and more things I need to keep in mind with every action I add, and that also means it'll get ugly for modders. So I started looking at the forward approach again, and I finally realized there's more symmetry to the problem than I thought. I thought starting from the goal's requirements was an advantage, because I only look at actions that can satisfy them, but starting from the initial state is an equal advantage, because I only look at actions that are possible from that current state. In both cases, the more I branch out, the farther I get from anything known. There's nothing guiding the AI toward the state at the other end of the path. It's just a matter of trying combinations until it lands there by chance, or hits a predefined limit and gives up. However, while working on my forward implementation, I did find one heuristic that should help. The biggest contributor toward combination explosion is the wide variety of places you can move, so I've added the ability for goals and actions to suggest locations. Moves to those locations are prioritized above anything else of equal cost. Better yet, those suggestions can be context sensitive. If a unit is trying to steal cargo and isn't carrying it yet, the first move the AI will try is toward that cargo. And if the unit is carrying cargo, the first move it will try will be toward their ship. In fact, perhaps the AI should only ever move toward locations suggested by an action or goal. Even for the purpose of avoiding danger, the in-turn action can suggest the safest locations within range. It may be possible to do an equivalent heuristic when working backward, but I'm pretty hard set on the forward approach now. I've got most of the pieces in place, but I still need to implement more actions, hook up the new AI code to the rest of the game, and undoubtedly do a lot of debugging. I'm hopeful that I'll have a working build in the next few days for my Patreon supporters, but it's hard to predict how long debugging will take. That's all for this week. Remember, if you'd like to support what I do, you can go to patreon.com/thoughtquake, or hit the like button, spread the word, and subscribe if you haven't already. And as always, thanks for watching.